We're going on now to Chapter 5, which is our last chapter that we cover in Math 100. We're going to do the first 6 topics. So here we're doing Introduction to Polynomials and Polynomial Functions. So we'll be dealing with the terms of polynomials, degree and coefficients, polynomial functions, graphs of polynomial functions. This relates to our Chapter 2 study. Adding polynomials and opposites and subtraction. These are the topics. Now we start off with a rather long matching. But the key here is, here are the terms we'll be using as we go through topic 5 or chapter 5, and will be useful in communicating. So you'll want to know these. So let's take a moment. We'll pause and then check them out. So some of these we can look at too. A binomial, bi is the prefix for 2. Cubic, we talked about in the form of a cube. Didn't do that one too well. And it's raised to the 3rd power. Degree is the sum of the exponents on the variables. Notice this has an S here in a term. So that's the definition of degree. Descending order. Here we have like power of 5, power of 4, power of 3, going down from left to right. The leading term is the term of the highest degree in a polynomial. Linear, where the polynomials are to degree 0 or 1. Remember, anything to the 0 power would just be the number, and the first power, like a to the first, we wouldn't write the 1 there. Monomial is just one term, and the prefix is mono. Quadratic, having at least one variable to the degree 2, so something that is squared. Now, quartic is a polynomial in 1 degree to the 4th degree, and quat is sort of like 4 quarts in a gallon or something, I don't know. Anyway, trinomial is to the 3 terms, tri being the prefix for 3. Okay, again, through usage, you'll master some of these, but it's something you'd want to be familiar with. Now, for number 11, I'll review what I said in class. Determine whether an expression is a true polynomial. Well, we said there were 2 things that would eliminate something from being a true polynomial. That is, if it had negative exponents, or as we write this, we would write that as 5 x to the 2nd minus 6.9. So this isn't a polynomial because it has negative exponents, and this isn't a polynomial. Remember, these 2 are equal because it has a variable in the denominator. So something that has a variable in the denominator is not considered a true polynomial. Although sometimes they just paint everything as polynomials. Here we're qualifying it with this definition: no negative exponents in the numerator, or actually if it was a negative exponent in the denominator, that would be good because that would come up. So it's no negative exponents in the numerator, and no variables in the denominator. All right, in example 12, they're asking us to identify the terms of a polynomial. And now we said terms were distinguished by either a positive or a negative sign. So we're kind of looking for that, or whatever sequence we have. So here, this is a positive. We just don't write it. So that's one term. Then we have a negative, goes up to there. That's the second term. And then we have a positive, and that's the third term. So we have identified the terms of a polynomial. This is 3 terms, would also be called a trinomial. Now for these next 2, they want to see, is it a monomial, binomial, trinomial, or if it's more than 3, it's just a polynomial with no special name. So this has 3 terms, so this would be a tri. This has 2 terms, so this would be a binomial. All right, determine the degree of each term in each polynomial. Well, we said degree was the exponents, the sum of the exponents on the variables in a particular term. So this one is 5, this one is 2, this one is 1, and this is 0, because there is no variable. Remember, it could be x to the 0 power is 1. When it's just the number, we say it's to the 0 power. All right, this one is 2. Now notice here we have a 1 and a 2, so this one is 3. A 3 and a 2, so this is 5. This is 1, and this is 0. Now as we look at these, we might say, well, what's the degree of this expression? Here they're only asking for the terms. But the degree of an expression is the highest degree of any one term. So in this one, it would be 5. That would be the degree of that expression. And this one would also be 5. And this is the technique you'd use. You just go through, figure out the degree of each term, and then what is the highest? That would be the degree of the expression. Number 17, determine the coefficient of each term. Well, the coefficient would be the number part in front of the variable. So this would be a -8. This would be a 5. This would be a 6. And this is a 3. Now, the 3 here is considered a constant. And notice we're not writing the plus or minus. We only write plus or minus when it needs clarification that we are adding these. And in this case, we don't write it if we're just listing the terms. Now, for this next one, for this polynomial, how many terms are there? Well, 1, 2, 3, 4. There are 4 terms. What is the degree of each term? Well, this one is 5. This is 1. This is 9. This is 7. What is the degree of the polynomial? Well, the highest degree is 9. So that's the degree of the polynomial. What is the leading term? Well, the leading term is the term with the highest exponent. So it'll be a x to the 9th is the leading term. What is the leading coefficient? Well, here's the leading term, so the coefficient of this term is a 1. Remember, if there's no 1 there, it is there. We just don't write it. Number 19, determine the degree of the polynomial. Well, again, a good technique is write the degree of each one. So that's 4. This is 2. This is 5. And remember, there's a 1 there, so this is 7. So the degree of this polynomial is the largest, which is 7. Arrange in descending order. So this would be first, this would be second, this would be third, this would be fourth, and this would be last. So it's just 5, 4, there is no 3, then you would go to 2, then you would go to 1, and then you go to the 0. Now remember, it's x to the 0, not the 4. All right, and this one, the same way. This is going to be the first, y to the 8th, y to the 3rd, y to the 2nd, y to the 1st, y to the 0. Now, this one is in ascending order, so we're looking for the lowest, which would be x to the 0, x to the 1st, x to the 3rd, x to the 5th, and x to the 7th. And of course the other stuff goes with it as well. Now, for this one, it's still arranged in ascending orders. So again, this would be in one of the terms. So let's see here. This is to the first, this is to the second. I think this one is pretty good, but let's take a closer look. Now, when I looked at the answer sheet, it showed that they wanted apparently the x's to be in ascending power. And so we could put the highest power of y here, and then this one would end up here. So it's sort of like the reverse of y, or descending of y, ascending of x. Again, I wasn't too sure about that, so I had to check the reference. And if you're not sure about something, ask. Okay, now for number 24, they're kind of going back to what we did in an earlier chapter. And for these, in a sense, you could make a little t-chart. And here, this is going to be g of x, which is our y value, remember. So here they say if x is 3, what will y be, or this? So this is going to be a negative 7 times 3, a negative 21, plus 15. This will give us a negative 6. And then here again, you don't need to make a t-chart. I'm just trying to show you how to organize the data here. This is going to be h of x. Remember, that could be a y. And we're saying we have x is going to be 3. So here we're developing a skill of substitution of a value where the x appears in the function. So here x is a 3. 3 to the 3rd power is 27. A negative 8 times 3 squared, which is 9, is a negative 72. Plus 3 is a negative 24. And here we have 2 for our x. And when you process it, do the computation, you end up with 4. And for here, you end up with 428. Again, this is just substitution. We want to show you how to do it. And if I worked every one out, it would make the tape quite long. So here again, our x in the first case will be, or in this case a t I should say, is a -5. In the second case it's a 0. And here we get, with a -5 substitution, 177. With a 0 substitution, we can almost do that. This is 0, this is 0, this is 0. It's going to be a -3. Okay, and number 28, they're giving us a formula for the falling rock. How many feet till it hits the ground? And we just substitute for t there, 4.5, square 4.5 first. That gives you, I believe, 20.25 times 16 gives you this. Looking at this one, here's our formula. And we know t, the time, is 12 minutes. So we carefully introduce the 12 minutes as t. And using our calculator, keep in mind this is negative, add this, and round it off to the nearest whole number, you end up with about 8 words. And that would be pretty good. Okay, what we want to do here for number 30, and this is a review from earlier chapters, is to find out what would the range of this be. And the range, as we see, would be, keeping in mind this goes up to infinity here. If I can get an arrow, yes. And this goes down to -infinity. Our range would be from -infinity to +infinity. Oh, I had trouble making a parenthesis. There we go. Now, the range for this one, keep in mind, range are y values. So this goes down to probably right there, which is -18. And we'll assume that it's in the set. So it goes from -18 up to +infinity. Now, we're not going to use a graphing calculator, so we're going to skip these two. And now they're just giving us some practice in combining like terms. So what I want to show here is what strategy, what technique might you use? Well, I think going down the row, we want to identify our like terms. So anything with an AB, just a plain AB, would be a like term. Then if you had the ability to do different colors, here we have a squared B, and here we have an a squared B. Oh, my daughter had a question for me, and she didn't realize I was recording. And our last like terms would be like, if you can see that, in yellow. So then it's just a matter of adding the signs together. So for our trying to keep it in some sort of order here, let's do these first, the ones in blue. We have a -7 now and a +5 give us a -2 a squared b. And then now we have something in red. So we have 3 of these, and a -1 of those leave us with a positive 2ab. And then our yellows, we have a positive 1 of these, negative 2, leaves us with a negative b squared. And notice we don't write the ones usually. Well, I noticed when I was checking the answer, I said, wait a minute. These are not like terms. The one I had in blue, and I had this in blue. That was when my daughter came and I was distracted. So here we have a squared b. Here we have a b squared. So these are not like terms. Now we can put it in order. So these two could go first. That would be a 2ab. Oh, I'm using green. And then I don't have any of these, so I can give them a 7, negative 7a squared b, and then a plus 5ab squared. And then again, we're subtracting a negative 2 from a 1, so that leaves us with a b squared. Okay, so you need to be careful and you need to check your work and try not to be distracted when you're doing something here. All right. Well, in a way, this up here was sort of a good lesson. Is there another way if you don't have colored pencils? Well, another way would be this. That is, take the first term, put it right there. Then go along the whole list of the expression and see if there's a like term. Ah, there's a like term, negative 8x squared. So put that under this. Then take the next one, a negative 7xy. And then look and see if there's another like term. Yeah, there's one right there. Put it underneath. Now, this next one, there is no like term. Then there was other than that. And then this one. So now you have developed something that I like to call like term columns. So let me see if I can get to that there. There's a like term column. There's a like term column. And there's a like term column. Okay, by putting them in like term columns, it really reduces getting unlike terms added together. Okay, now notice when you do that, you're only adding the numerical coefficients. The variable part does not change. All right, let's set up the next few like this. So as we see this, these are two sets of parentheses with a plus sign between them. So theoretically, we can just take away the parentheses, and I'm going to put my terms in like columns. Now notice for this negative b, I put a 1 there. You can do that. That's okay. Again, in your answers, though, you shouldn't write it, but I wouldn't take off. And by doing that, you're just adding up your like term columns. Now in 37, 38, again, just develop like term columns. Add them up. The answers are in the back of the chapter. And 39, that's sort of a little tricky. So let me do 39 for you here as I move it up. Now, as we look at this, again, I put them in like term columns, but we also needed to have equivalent fractions so that we can actually deal with the fractions. So here 1/5 becomes 2/10. So 2/10 plus 7/10 is 9/10. And then the negative 4/5 becomes a negative 8/10. Plus 3 gives us a negative 5/10, which reduces nicely to a negative 1/2, a to the second. And we just combine these and end up with that. Okay, going on to this next one, they're asking us write two expressions, one in parentheses and one without, for the opposite of each. Well, basically what they want us to do here is to reverse all the signs. So if we take out a negative 1, we put a parenthesis around it and then change all of the signs. So this will now become a positive 6 and that, and this will become a negative 7 and that, and this will be a positive 9 in that, and this will be a negative 8 and that. And it's the same thing here. If you take out a negative, it reverses all of the signs. So this becomes a negative 3, this becomes a positive 4, this becomes a negative 9, and this becomes a positive 2. So this is a technique we had earlier when there was a negative sign outside. We said take away the parentheses and then change all the signs inside. So this is what they're building us up to in the next little part, which is how we do subtraction. We do subtraction by taking away the parentheses and then changing all of these signs. So this then becomes no change here, but now this becomes a positive 5r and a negative 10. And again, I'd use that same technique of lining them up. So this would be 3r minus 1 over, let's see, under 5r minus 10, like term columns. So this gives you an 8r plus 11. Now I'm not going to do all of these. I'll do number 46 for you because that's sort of tricky, but the rest, just change these signs. This becomes negative, negative, positive. Put them in like term columns. Negative becomes a positive here, becomes a positive there, becomes a negative, like term columns. Now again, you want to recognize what subtraction is, having that negative sign between them. And we change it to addition by removing the parentheses and then changing all of these signs to their opposite. Okay, let me do number 46 for you. This just made it a little tedious, but hopefully we develop a technique. Here, we're lining them up in like term columns, but since this was subtraction, I had to change this sign, making it a negative 1/2, this a positive 3/4, and this a positive 1/8. And then in blue, it shows the equivalent fractions, so I get a common denominator. So here, this is a negative 2/4 plus 1/4, a negative 1/4. Then this is 3 from 6 is 3, and this is negative, so negative 3/4 t cubed. And now it's just a matter of adding the 2 and the 1 to give us the 3/8. Here again, just change these signs, not here. Line them up in like term columns. And again, you're changing just these two. Then combine like terms. Okay, we're not going to be using a graphing calculator. And as we complete this, I believe we are finished with section 5.1. Again, some of these are challenging. You earn the right to do well on your test later by doing your practice and quiz me's and mastering these skills.